So looking at example 1, so our function or our equation is y equals negative 3x plus 3. Now we know our slope is next to our x. It's our m. So our slope is negative 3. Okay? Now we've got to keep in mind that we need to see this as a fraction, right? We need our rise over our run. Okay? So that means that we would have a rise of negative 3 and a run of 1, or a rise of positive 3 and a run of negative 1. Okay? So this negative can go on the top or the bottom. It doesn't matter as long as there's only one negative. Okay? Our y-intercept is our b. Okay? So we've got our m here, our slope. We've got our b here, which is our y-intercept, and it is a positive 3. So our y-intercept is positive 3. So let's go ahead and get this graph. So our starting point is our y-intercept, right? That's where we start. So our y-intercept is up here at 3. Okay? So here's my starting point. Now my rise is negative 3. That means I'm going to go down 3. And my run is positive. That means I move to the right 1. So down 3, right 1. 1, 2, 3, to the right 1. Okay, now I've got a new point here. I can do the same thing. Down 1, right 1, or down 3, right 1. So a rise of negative 3. So 1, 2, 3. Run of positive 1 to the right 1. Okay, so keep in mind we also wrote our slope as positive 3 over a negative 1. That means if I go back to where I started from, I could go up 3 and left 1. Okay, positive is up, and this negative means left. So I could have gone 1, 2, 3, and to the left 1. And notice it falls in line with all of my other points. Okay, so then I could just draw my line connecting each of these points. Okay, so I need my x-intercept. I can't forget about that. I got my y-intercept at 3. Crosses my x-axis down here at 1. If I were to write these as ordered pairs, my y-intercept would be at 0, 3. My x-intercept would be at 1, 0.